Okay, so here are some extra examples from section 10.2. Um, in the first example, you're supposed to solve for x degrees, or just x in this case. Well, the thing is, it's a central angle because it's got a vertex at the center, and its sides are on the circle. Excuse me. And all four of these angles together have to add it to be 360. So if I add up the three that I know, 150 plus 90 gives us 240, plus another 85 gives us 325 degrees. So 360 minus 325 will give us our leftover degrees, 35 degrees. Okay, so that's x. All right then. Next example. I'm not going to find all the measures of these arcs, so that would take a long time to do. Most importantly, what I'm going to do is find the missing angles and then just kind of talk about that. So the first thing I would do for a problem like this, if it were me, is I would find all of the missing arc angles, central angles in the drawing. And then once I know that, I'll know my arc angles, because the arc angle is the same as the central angle. So the first one I could find is ABG, because these two guys are vertical angles. So that's 55 degrees. Plus, you're told that AD and CG are diameters. So that means that this guy here from A around to D this way is 180 degrees. Well, 55 plus 35 is 90, meaning this has to be 90 degrees left over. You're also told that AD is a diameter. So that means that A to C to D is 180 degrees. So we've got 55 degrees. That means there's got to be 125 degrees left over to make up the 180 for the whole half semicircle. Okay. So now once we know that, we can just kind of pick at random which one we want to look at. 16 I know is a minor arc because it's only got two letters. And the shortest distance between C and D is 55 degrees. If I look at 20, 20 is GCF. G to C to F. So we'll look at 20 next. Look at 16, 20, I don't know, 21, let's say. No, 21's out of screen. Let's look at 23. I think I can see, yeah, 23. So I have to realize I'm going from G to C to F. Now, in order to do that, I can't go through F. I have to go away from F, so I have to go around this way. So here's G to C to F. That's the arc we're talking about. Well, GCF is a major arc because it's three letters and it's not a semicircle. And it's all of everything but the 335s, or the 35 degrees. So 360 minus 35 is 325 degrees. And then I don't know, what do we got here? We got ACD anywhere in there? Yeah, number 21 is ACD. Let's do that. Okay. Well, I'll just highlight this. For A to C to D, okay, that leaves us along the diameter of AD, meaning that ACD is a semicircle, which is 180 degrees. Okay. Next example, finding arc length. Okay, physical length, not angle length. So 36 says, find length of RS if the radius is 2 inches. Okay. Well, the real way to find arc length is to realize that it's just part of the circumference. So to do 36, first I would do is just find the circumference. Circumference is 2 pi times the radius, since I know the radius. So it's 2 pi times 2, 4 pi inches. And it says nearest hundredth, but let's leave it exact for now. So the circumference of the circle is 4 pi. Now there's two ways to figure out the arc length. One is to use the proportion. Okay, I know I've got a 130 degree angle for that angle. Okay, so it's 130 out of 360, because 360 is the whole circle, is x length, out of 4 pi. Because that's the whole circle, that's the whole circumference. This is the part we're looking for, just part of it. You can cancel it down a bit. You can also multiply by 4 pi. It becomes 9 and 1. So circumference is 13 pi over 9, yeah, which is a decimal, 13 pi divided by 9 is 4.53, no, 4.54. And what do we got here? Inches. Now you do the same thing for 37 and 38. You're just doing different angles. So, same idea. The other way you could do it is this. Circumference is the angle that you have, which is 130, out of 360 times 2 pi times the radius. Or really, it's times circumference. That ends up getting you 13 over 36 times 9 pi. 4 goes down here. 1 goes up there. No, it's 4 pi. Come on, Mr. Moyer. 4 pi, and this becomes 9. There we go. So that cancels off, and you get 13 pi over 9 again. Okay. So you could still do the angle over 360 times the circumference. All right. Last problem. You're trying to find the measure on 45 of the circumference. So this is a case where it's nice to use that proportion, because here's the deal. I know I have 70 degrees out of the 360. 70 degrees gives me 7.94 inches. My question is, what's the whole circumference? So what I can do then is I can just cross multiply and solve. It's just a proportion at this point. And solve that guy. So 360 times 7.94 and then divide by 360. And I get, oh sorry, divide by 70, excuse me. It's been a long day. 40.83. Yeah. Okay. Number 46 I like too, because you're actually working backwards to the angle. And this is again another case where it almost makes it nicer. Well, you can use the equation in this case because you've got your radius, you've got your arc length. Okay. So arc length is the angle over 360 times 2 pi r. Okay. Well, the nice thing about this one is the 2 and the 5 cancel off. So basically it's 131 equals x over 360 times pi. I would multiply 360 to cancel it off. So 360 times 1.31. Which is 471.6. X times pi. So divide by pi. So divided by pi. And we get 150.11. So the angle, the arc angle is 150.11 degrees, because that's the central angle there. Same thing as the arc angle. Okay. And that was section 10.2.